Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode, we're going to talk about reusable rockets as an overview, what is the new thing in 2020. So first you have to understand the idea and history behind it. Now you have to understand rockets are expensive. Even back in 1969 it was super expensive. Saturn V was ludicrously expensive and Energia rocket from USSR was even more expensive. So people knew from day one rockets are expensive and it is not a good idea to throw them away unless they are ICBMs. So you have to understand that the reason why nobody could reuse a rocket properly back then is simply they did not have the spare power. You have to understand that this is the early days of rocketry. Like rocket engines are barely producing power, they're barely putting things in orbit reliably, so to say. So in that time, think of it this way, like your satellite needed let's say 100 energy in order to put it in orbit, but your rocket was barely capable of doing 110. Would you risk that extra 10 in any way? No, you will be like, dude, I need that space just to make sure that orbit is perfectly circular or perfect altitude. Now as we understand about fluid dynamics, aerodynamics, better fuel burning capacities, better engines and all that, then we got the spare power to do anything, because everything you want to do in basically universe, you need energy for that. We did not had that spare energy in the first place. That is why Saturn V, even if they wanted to, they could not reuse it, simply because to go to the moon it required so much delta V. If they try to reuse it, they will be like, yeah, our payload capacity went from 150 ton to low earth orbit to 50 ton to low earth orbit. So that is the whole reality of it. Now even with that, as engines started to become better and better, people did try to reuse it. I mean, space shuttle is a proper reuse vehicle. Yeah, it's not 100% reusable, but they did try to reuse the basically outer casing of solid boosters, and the main shuttle, basically rocket engine was completely intact, crew compartments were basically this whole thing came out. Only fuel tank was 100% disposed, and solid booster they had to refurbish. Now again, that was an idea, but economics did not work out. It was too complicated to who was in this, so it did not work out that well. On top of that, while this was going on, people started with McDonnell's Douglas DCXA. Now this is literally the foundation on which SpaceX system is built. You have to understand this idea. Like space has had the luxury of that. There are many projects before basically SpaceX that tried to do this and failed. Now all of them had some teachings, because think of this way. Let's say right now ISRO wants to make a, let's say, reusable rocket, and they are like, hey, we have to have grid fins. Now from day one they know that they cannot use aluminum grid fin, because they have seen SpaceX using it. They have seen the consequence of that. Like, yeah, it's cheap, but it keeps destroying itself, you have to keep replacing it. It's cheaper to get for titanium. Or they might be like, how about we reduce our payload capacity a little bit, but go with steel. It's cheaper, but it will not melt. So you get the idea. Like every time somebody fails, you learn something from it collectively. So a lot of research and development was done. This engine was completely capable of like going so you have to understand this. Like many times I see people like, SpaceX tried to do something that could not have been done. Like people did try to. It's like that time technology was not good enough, computers were not good. Heck, the computers that space shuttle had was like, in tons. Right now you can do that in like, few kilograms. So people did try to do that. So whenever I see somebody like, SpaceX meet something impossible, no, they got the luxury of other people failing beforehand. So what do you need in order to truly reuse something in fundamental level? Like what the heck do you need? Well, you need spare fuel for landing. Now this is one of the amazing things about SpaceX built a rocket from day one with Mars goal in the mind. So the rocket was overbuilt like crazy. So even though NASA was like as a main contractor, they were like, dude, we only need to send some tons of fuel, basically some tons of resupply to International Space Station. But again, SpaceX overbuilt from day one. They were like, dude, we can overbuild it. So their target was like from the version 1, let's call it, was 10 tons, which was already overbuilt. Then they keep pushing it, and right now they are around 20 tons. So that is the whole idea, that because they have such a large spare margin, and their satellites are barely, especially if they are sending something to low earth orbit, is barely like 1 ton or 2 tons. They're like, yeah, we have more than a spare margin to attempt a re-landing. And that is why even many times you will see SpaceX saying we do not have enough margin for landing, because again, what if you are putting something that requires that 20-ton capacity, specifically with geostationary mission, you really need that like last oomph. So you have to have spare fuel. Either you build your rocket ludicrously huge, you do not go governmental route where like build as cheaply as possible, and if you are like, oh, we need 10 tons rocket right now, build a 10 ton, and you're like, oh dude, we need 12 ton now with better satellite equipment and all that, yeah, strap on some boosters. This for a reusable system, you have to have a spare system from day one. Then your engine must be capable of relighting. Now relighting is very tricky thing, and if you have seen any SpaceX live broadcast, you must have seen that green flame. I will explain what is that in later part of this video, but relighting a rocket engine is very tricky. Very few engines can reliably do that. And because when you are talking about basically landing, you need energy for that, you need guidance for that. So space shuttle, even though it was like gliding force, that's why it needed runway. But if you want to land on something like this, you need rocket engine like Douglas system. And relighting thankfully has become, from 1970s to 1980s, it became very clear it's much more efficient to relight a second stage engine in orbit to correct for geostationary orbit rather than requiring a rocket in the satellite itself. So people have figured out how to use relightable engines, so SpaceX got the benefit of that. Then you have to understand that if you are coming in from even as slow as Mach 5, it's not close to orbital speed, you are still talking such a fast speed that if you unbalance your craft, basically when you are instead of going through the atmosphere, you are fighting with the atmosphere will win, which you can easily see in the recent demonstration of safety precaution. Basically they ditched the max Q ejection system, they tried it, okay, everything worked, but the rocket ended up directly fighting the atmosphere, and atmosphere is like, bro, what are you trying to do? You're gonna be disintegrated, and it was done. So you have to control the atmosphere, you cannot fight it, you have to glide with it. That is necessary. So you must have a way to properly aim yourself in space, and when you are going through the atmosphere, properly control yourself. So that is why the grid fins are so important. Then we come to the heat management aspect. Even if you are not talking about basically second stage, the first stage still going Mach 5, still going like as high as 10 to 30 kilometers, or sometimes even higher. So dropping from that altitude, while you again, your rocket is mostly empty right now, but still multi-ton object, it's gonna heat up like crazy. So you have to have some way to manage the heat. Then you have to figure out how you're going to land it. Now landing support is very critical. If you have seen early videos of basically SpaceX landing, the landing legs have collapsed many times. It's like it landed and legs collapse and boom, things happen. So you have to design for landing itself. Then there is another way of landing, is basically you don't land at all, because landing is very difficult, requires legs or proofing everything, which is very tedious. So electron rocket, which is a small rocket, it does not have enough margin to have landing legs. So what do? They're like, okay, deplete the rocket completely, just have engine to enough to guide it, steer it, and be like, okay, I'm coming in. And then use parachutes. The benefit of parachute is that it will not touch anything, so they do not have to introduce the weight of a landing leg. However, they must have helicopters on standby when it's landing, and if the helicopter miss, it's done. It's useless. So landing system is a complete support you have to figure out. In case of SpaceX, they have to figure out that batch system. So what about Falcon 9? Now Falcon 9 right now is amazing. It's a most successful system out there, flat out, and they have learned a lot from their previous basically Falcon 4 versions, basically Falcon 9 version 4s, and they realized aluminum feels, while cheaper, it used to melt, it requires so much repairing. They're like, dude, just throw it away, just let it go. So they finally moved to titanium grid fins. Again, expensive, but it runs for survives so long that they're like, it's like buying better and then not spending money on repairs. Then cold gas thrusters was a necessary thing that they figured out, that in space, even though when you are entering the upper thin atmosphere, you really want to be in like perfect shape. Like you don't want to fight it even then. Like again, your rocket may survive it, but it may get cracked. And metals cracks are very hard to find. So you really don't want to fight it. You're like, okay, I'm going to guide it perfectly. So the ballistic trajectory lines up with your aerodynamic desires. So cold gas thrusters really helps. This is what you see push, push, push doing in the landing sequences. And landing legs, this also became so important that now they have crush zones in them. Again, they had from day one, now they have fine-tuned it. That is why you rarely see nowadays that legs getting damaged during landing. Even if it gets damaged, the rocket does not tip over, which was a very big issue in the early models. So they have a crush core, basically giant aluminum foam block, quote unquote, honeycomb, yeah, honeycomb, and it crashes. So rather than sending energy to the chassis, which if dented, it's use and throw, but they do not want to dent the chassis, so they have a crush zone. Basically those puppy will absorb the energy, they will get destroyed, but the leg will survive. They have to just open it up and replace that part, and the chassis will be completely intact. So again, these are the things they learned after doing it, experimenting with it. And heat shield is a normal thing. Basically every time, the main problem with heat shield is that we know how to make heat shield, it's just we have to make heat shield light enough. So are there any problems with Falcon 9? Absolutely, it's physics, reality. So the problem with, main core problem with Falcon 9 is basically it's dirty boy. So the engines are dirty and the fuel is dirty. What does that mean? The engine is dirty. Engine is dirty because it does not have electrical ignition system. It relies on T-tab ignition system. That means there is a third propellant system that they have to figure out how the heck they're gonna have manage it. And you must have seen many whole streamings where they're like, dude, we ran out of T-tap, so rocket reignite failed. And that is a very big concern. That is why Raptor engine is like, nope, I'm not touching T-tap, I'm gonna going full electric, so they can restart it much more time. And T-tap itself is a very volatile hoo-ha. You don't want to toy around with it. And then we come to the fuel aspect. Now fuel is the inherent limitation of this puppy, because they are using kerosene. Now kerosene is not a good fuel or bad fuel, it's simply a fuel. Problem with kerosene is because they are not basically using what we call open cycle, and they have a scenario where going burning what we classify as fuel rich, basically 1 liter of fuel, very little oxygen, and tada, so you get hot exhaust. That hot exhaust is cold enough that you can turn the turbine without melting it, but because it's fuel rich, it creates a lot of soot, and that soot is created in a high oxygen environment. So basically it's gonna stick to metal and gonna destroy it on a chemical basically chemical level. And that is the reason why these engines can only be used 10 times. And even that is like pushing it, because the turbine starts to get damaged beyond repairable limits. So inherently, because of the fuel they are using, because of the architecture they are employed, it cannot run for it. Because you may think, oh, it's getting blacked out because of jet engine, sorry, rocket engine. No, it's getting blacked out because of the pre-burner, so to say. Pre-burner is making this all blacky and sooty and destroying the turbines and all that jazz. So that also has to go. Second stage, right now as it's designed, it cannot be reused. Now you might be like, what if they have to only send something, let's say lightweight, let's say a few kilograms in low earth orbit? Doesn't that mean this puppy would have more than enough spare delta V? Absolutely do. The problem is the engine bell is designed for vacuum optimized. So the moment they will fire this vacuum optimized engine in atmosphere, the engine will create, basically this is the nozzle, you can have the flow will separate, because again atmosphere is pushing it. Now when the moment you have that, it will cause an oscillation, and that oscillation will go boom. You really don't want that. That is why this nozzle is not convenient to relight it. You cannot relight it in atmosphere, it will self-destruct. So these are the inherent problem with this. Like you can't bypass this. These are the inherent problem with this. So what we can expect in the future? Again, SpaceX have figured it out, and Blue Origins have already successfully landed their rockets. They did it first, but again, it was non-orbital system, but they have also learned a lot, and they are also moving to a cleaner fuel. Because the more closer to you come to hydrogen, the better your engine is, the but more mileage you get, but your basically thrust, the oomph that you have goes down. You want to have carbon for that oomph. So kerosene has a lot of carbon, but problem is sooty output. Hydrogen is awesome, clean, and that is why shuttle engine was completely reusable. But side effect is inherently weak. Basically, you gonna have huge tank and still not gonna have enough power to get off the ground. You have to have solid boosters. So what you gonna do? Basically, how about find the middle ground where you have just enough hydrogen to get the mileage, but enough carbon to get the oomph. Methane is the perfect choice for that. So all the engines that are gonna be reused for in the future missions will be methanol engines, CH4 and L, liquid oxygen. Benefit of that, even if you burn it fuel rich, there is no probability of soot creation. Like flat out, you don't even have to think about it. It's like you burn fuel rich as much as you want, you're still gonna get vapor rather than soot. So that inherently makes the engine last longer. Then the engines, again, we learned a lot, like SpaceX learned a lot, Blue Origin learned a lot, and they're like, yeah, this is how we're gonna design the engine which can support multiple reuse. And most of them are going with electrical spark system. And second stage will be now designed with complete goal of reuse. That is why they have sea level nozzles, because if you fire vacuum optimized engine in atmosphere, you're gonna go Europe. And better heat shields. Because SpaceX have the luxury of actually having a craft going into orbital velocity and landing, which is known as Dragon system. That is giving them a very good testing ground where they're gonna test out. Oh, this is how a heat shield works. This is how much weight we can remove, while still maintaining it, safety standard and all that. Because that is going through NASA. It's double checked, triple checked to the nth degree to make sure that it is safe enough. So all these things, basically, the core change that's happening is we are making cleaner engines. We are making engines that are far more efficient in terms of how the heck you're gonna reignite that puppy, and because of the better heat dynamics. And again, second engine stage that has the engine's capability of relighting itself in atmosphere without destroying itself. So all these things will allow us a future where we're gonna have this booster combo has been used for 30 times, because this engine supposed to able to run around 50 times before they need to replace it. So again, our future is kind of bright, and at least one of them will figure it out, like 100% reusable rocket. And I'm reasonably sure by 2030 we will miss, like this will be a common thing, and that time government will finally start to catch up, like, yeah, we are also gonna make reusable rockets. So this was my presentation on basically reusable systems. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.